Okay, going to look at forming or modeling differential, can't say it, equations. So, let's look at it, for example, here. So the rate of increase of a rabbit population, or population P, where time is T, is proportional to the current population. Form an equation and find its general solution. Okay. So we are told that the rate of increase of the population is proportional to the current population. Okay. And do we have anything? Okay, fine. So the change in population with respect to time is proportional to the current population. So in other words, the change in population with respect to time equals a k constant multiplied by the population. Okay. Okay, so I'm going to divide, in this case, both sides by p. So 1 over p multiplied by my change in population with respect to time. That equals k. So I'm now going to integrate both sides with respect to time, like so. So they're going to cancel out essentially. So we've got the integration 1 over p dp equals the integration of k with respect to t. So that gives us the natural log of p equals, now this is a constant, so kt plus c. So population equals e to the power of kt plus c, and that equals ekt multiplied by e to the c, and that here is just going to become a new constant. So my final answer is p equals that new constant a multiplied by ekt, and we're done there. Fantastic. Okay, so let's look at the next question. I'll zoom out there so you can see that. So a nice little rabbit. Okay. Okay, new example. So we've got a water in a manufacturing plant. It's held in a large cylinder tank of diameter 20. Water flows out the bottom of the tank through a tap at a rate proportional to the cube root of the volume. Okay, that's probably going to be important in a moment. Okay, so that t minutes after the tap is open, dh over dt equals minus k cube root of h for some constant. Okay, so let's do part A. So we've got volume equals pi r squared h, and that gives us, we got the radius is 10, so we've got 100 pi h. We're trying to find the change in height of the water with respect to time. Okay, well, the change of volume with respect to h, that is 100 pi. And then we can say, okay, so we're telling the question that the water flows out of the tank at a rate proportional to the cube root of the volume. Okay. So the change in our volume with respect to time, it is proportional to the cube root of the volume. And the water's gonna be decreasing, so we're gonna get a negative C in there. That'll just be our constant. And like earlier we had K, and it's gonna be the cube root of the volume. So we're getting this from that highlighted section up there. Okay. We have the volume here, so I'm going to rewrite that as minus C cube root of 100 pi h. Okay, so now we want to find dH over dt. That's the goal of the question here. Okay. dH over dt, I can say is dH over d3 multiplied by d3 all over dt. And what we can see here is they're going to cancel out to give us dH over dt. Okay. dH over d3 is the reciprocal of the one up here. So that's going to be 1 over 100 pi multiplied by d3 over dt. And that is up here. So I can say minus C cube root 100 pi h. So the final answer is one moment. Minus C cube root 100 pi h all over 100 pi. Okay. And we want to find out what the K constant is. So, okay, we want to write it in the following then. So minus C times the cube root 100 pi times the cube root of h. I'm splitting it up because up here all over 100 pi. So minus K in the question equals minus C cube root 100 pi all over this bit here. So therefore K equals, I can make it positive now, 100 pi all over 100 pi. So that's just a cube root 100 pi. Okay, that's the first part done there. Okay. By part B, so that the general solution of the equation may be written in the form h equals p minus qt to the power 1.5 where p and c are constants. Okay. Right. Okay, so we've got here, we've got the following there, right? So dH over dt. Let's have a look at it. So part B. dH over dt, that equals, and what we're going to try and do essentially is we'll let to integrate this as the goal. So we've got minus K, which we found earlier to be here, but I'll write it in this form, save myself some time, and we've got h to the power 1/3. Okay. What I'm going to do now is I'm going to divide both sides by h to the third. So I'm going to get essentially 1 over the cube root of h, which I can write as h to the negative third times dh over dt, and that equals minus k. So what I'm going to do now is, if I should get some space, I'm going to integrate both sides with respect to t, like so. And that's going to give me, so essentially they're going to cancel out. So the integral of h to the negative 1/3 with respect to h, that's going to give me, I might try and squeeze it in underneath. Add 1, so 2/3 divided by that. 3 over 2 h to the 2/3, and that's going to equal minus kt plus c. Fantastic. Okay, let's get what we're trying to see. We're trying to get h by itself. So let's divide everything by 3 over 2. So if we divide everything by 3 over 2, we're timesing it by 2/3. So h 2/3 equals 2/3 times minus kt plus 2/3 c. Okay, and now we're going to do everything to the power of 3 over 2. So therefore, I'll try and get some space now. H equals, put this all in a bracket, minus 2/3 kt plus 2 over 3c, all to the power of 3 over 2. And there we are. And that's the form we wanted in, because the original question was asking for p minus qt 3 over 2. So p here is minus 2/3 kt. Oh no, it's not. I got that backwards. Sorry. P is 2/3 c, and minus q is minus 2/3 k. Fantastic, done. Okay, that's part B. Right, P and Q we done then, so we can just, yeah, you place the K, that K here, that minus K is up here. You can see it there. Okay. Right, let me try and get C and D done now. So part C, try and squeeze this in. Find the constants. Oh, find what P and Q are. Fantastic. Okay, so we're told the initial height is 27, and 10 minutes later it's 8. So what we can say here is when t is 0, the height is 27. Okay. So let's look at our equation down here. So, so 27 equals, well, t is 0, so that becomes 0. So it equals p to the power of 3 over 2. Therefore, p has to equal 9, because 9 to the power 1.5 is 27. Fantastic. We are also told in the question, 10 minutes later, height is 8. Okay. So when t is 10, height is 8. So using that same formula, we've got the height is 8. 8 equals p, which we find out to be 9, minus time is 10 cubed, 1.5 there. Okay. What we can do now is I can, well, if I make that 3 over 2, what you see what I'm doing. If I raise everything to the power of 2/3 here, they will cancel out nicely. So 8 to the power of 2/3 is 4. That equals 9 minus 10q. So we add 10q to both sides, and when 9 take away 4 is 5. So q equals a half. Fantastic. So there we are. That's p and q done. Okay. Part D, find the time in minutes where the water is at a depth of 1 meter. Okay. So I think we've got our equation now. So we can go H equals 9 take away a half t to the power of 3 over 2. So all I've done there is I've substituted the P and Q values in. We want to get a height of 1. So 1 equals 9 minus a half t power of 3 over t. Fantastic. So we need essentially 9 minus a half t to equal 1. So 8 equals a half t. Therefore, time is 16 minutes. And we are done there. Fantastic. Good question. Okay, great. Okay. Here is a question to test your understanding, and I've got a hint as well. You want some more practice afterwards. Edexcel 2008. Question 8 is a good one. So let me zoom in here. Okay. So you can pause the video and have a go at it. And I'm going to try my best to talk through it. So liquid is pouring into a container at a constant rate of 20 centimeters cubed to the s negative 1 per second. And it's leaking out at a rate proportional to the volume of the liquid already in the container. Explain why at t seconds the volume phi of the liquid satisfies the following equation where k is a positive. Okay, so dv over dt is the rate of increase of volume with respect to time. That makes sense. And it starts at 20, which we can see in the question. That makes sense. And negative k phi is just telling us, so k is the constant of proportionality, and the negative source is a decrease. So therefore, the rate of volume with time is changing from 20, take away the proportion of the volume of the liquid, which we can see here. Oh, sorry. So essentially, this minus k phi part is leaking out at a rate proportional to the volume there. So that's what we're just doing a sentence explaining that. Okay, great. Right, that'd be 2 marks there. Right, part B. The container is initially empty. Okay. By solving the equation so that phi equals a plus b times e to the negative kt, given the values of a and b. Okay, so let's see here. Right. Okay, so d phi. What I'm going to do is I'm going to divide both sides by 20 minus k phi. So 1 over 20 minus k phi times d phi over dt. That equals 1. Okay, so what I'm going to do, I'm going to integrate both sides with respect to dt. And they're going to cancel out quite nicely. So what I'm going to get here is I'm going to do natural log 20 minus k phi. And then when I integrate, if I was to go the other way, I would do 1 over 20 minus k phi multiplied by negative k, which I don't want. So to counteract that, I need to add on a minus 1 over k on the front of it, and they will cancel out. Great. And that's going to equal the integral of this, which is t plus c. Okay. So we are told in the question, initially the container is empty. So when time is 0, volume is 0. Okay. So that means we get the following equation. Minus 1 over k multiplied by natural log 20. That equals, so t plus c becomes 0. 0 plus c, I should say. So c equals minus 1 over k times natural log 20. Okay, fantastic. Put modulus, I don't have to put modulus, it's 20. Right. Okay, so now we can say, what do we need? By solving the equation, right, so we need to get volume on its own. So, okay. So I've got minus 1 over k natural log 20 minus k phi equals time minus 1 over k natural log 20. So if I rewrite this, t is going to equal minus 1 over k natural log 20 minus k phi plus 1 over k natural log 20. So time equals, I'll factor out the 1 over k, and we're going to get natural log 20 minus natural log 20 minus k phi. So therefore, that's going to clean itself up a bit. And time is going to equal 1 over k natural log, and we're going to get 20 divided by 20 minus k phi. Okay, so we want to get volume in the form a plus b e. Okay, so let's have a look. How am I doing? Give the answers A and B in terms of k. Okay. Okay. Right. So let's have a look. Bear with me. We want to get volume as the following. So what I'm going to do, I'm going to times both sides by k. So kt equals natural log 20 over 20 minus k phi. So what that means is e to the power of kt, that equals 20 over 20 minus k phi. There. So I'm trying to get phi as the subject here. That's fine. So we'll do e to the kt times it by 20 k phi equals 20. So multiply it out. So we're going to get 20 e to the kt minus k phi e to the kt equals 20. I'm trying to get some more space here. So 20 e to the kt minus 20 equals k phi e to the k over t. Okay. So I can divide everything by ket. Fine. So volume equals 20 e to the kt all over phi e to the kt minus 20 all over k e to the kt. So let's see, cancels out. Fine. So volume equals 20. Oh, sorry, that's k, my bad. Yeah, so 20 over k. Take away 20 over k multiplied by e to the negative kt, and we're done there. Is that what we wanted? Yeah, fantastic. So we've got it in the form there. So a here is 20 over k, and the b part here is minus 20 over k. Fantastic. Okay, great. Fantastic. Last bit on the home state. What is the volume of the liquid in the container at 10 seconds after the start? And we're given that dv over dt equals 10 when t is 5. Okay. Right, dv over dt is 10 when t is 5. So let's see, what are we doing? Well, we've got the volume here, fantastic. Well, dv over dt, we're going to be left with, I believe that's a constant, that's fine, and we're going to integrate this, fantastic. So we're going to do minus 20 over k multiplied by the derivative up here, which is minus k multiplied by itself. That's nice, that's going to clean up quite nicely. 20e to the minus kt, fantastic. Okay, we are told in the question, I'm looking at my notes up here, dv over dt equals 10 when t is 5. Fantastic. So 20e minus k times 5, so minus 5k. Oh, sorry. That equals 10. Great. So e to the minus 5k, that equals 10 over 20, which is a half. Right, yeah, half, yeah. Fantastic. So let's have a look. Let's do natural logs of both sides. Is that what we want? I think so. Natural log of e to the minus 5t equals natural log of a half. So e to the power of that equals that. I think that's right. Yeah. Minus 5t equals natural log of a half. So 2 to the negative 1. Half is 2 to the negative 1. To bring the power over, yeah, 5t equals natural log 2. So t equals 1/5 natural log 2. Okay, fantastic. So find the volume of the liquid 10 seconds after the start. Okay. Oh, sorry, that should be k. Silly. I don't know what I was thinking there. Sorry, I've used t as k. My bad. Let me fix that. K. Fantastic. So what is the volume of the liquid after 10 seconds? So we can pull this question out here. Volume of the liquid is 20 over 0.2 natural log 2 minus 20 over 0.2 natural log 2 times e. And we got, oh god, minus k, so minus 0.2 natural log 2, and we're going to do 10 seconds, so times 10. Right, I need to get a calculator out. Let me just type this in really carefully. Okay, so 20 divided by 0.2 times natural log 2 minus right, I'm going to be really careful with my brackets on this. E minus 0.2 times natural log 2 times 10. I've got an answer of 108.202. Let me double check that's correct. Fantastic. And there we are, done. So the 4 unit, there's a cleaner answer actually. I'm not going to waste time looking for it, but 75 over natural log 2, both are the same. Fantastic, there we are. I'm going to stop the video now. Hopefully that's been helpful there.